सो हे गाइस, वेलकम बैक टू हसन एसएससी वाला। और आज की इस वीडियो में हम लोग देखने वाले हैं मेंसुरेशन डे 22 का मेंसुरेशन 1 चैप्टर, जो कि 2D फिगर्स के लिए रहने वाला है। और ये जो सोर्स ऑफ इंफॉर्मेशन लिया गया है पेज नंबर 222 ऑफ ACE SSC एडवांस ई बुक अड्डा 24/7 से लिया गया है। एंड हेयर आर द लिस्ट ऑफ इम्पॉर्टेंट पॉइंट्स फॉर दिस चैप्टर. So the first point is this chapter is based on the measurement of length, height, hypotenuse, diagonal, perimeter, area of triangle, quadrilateral, polygons and circle, and these are based on for 2D figures. Second point is that this point is important, in which n is equals to d by 2 pi r, where n is the number of revolution made by a wheel which has traveled through a distance of d. Means if there is any wheel which has traveled d distance, then the number of revolution made by that wheel will be the distance covered divided by 2 pi r. 2 pi r will be the complete circumference. Means total distance by a complete circumference will give the number of revolution by the wheel. Now coming to the 2D figure. In 2D figure, if each side is increased by x%, if each side of any 2D figure is increased by x%, then its perimeter is also increased by x%, because if each side is increasing, then the length of each side is increased, then the perimeter is also increased by x%. This is simple. Second point is that if each side of a quadrilateral means the one which have 4 sides, if it is increasing by x%, then the diagonal is also increasing by x%. Next point is if each side is changed by x%. Now there is a change, means it can either be increased or decreased. Then the area is changed by the value of x into 2 plus x by 100%. X into 2 plus x by 100 is within the bracket. 2 plus x by 100 is within the bracket, which is multiplied to x. This much percentage is changed in area is noticed whenever a side is changed to x%. So this is important, that x by 100 is added to 2 and then the whole is multiplied to x. The fourth point is that if the area of a square is a, square area is a, then the area of circle made by the same square, means of equal perimeter, means the perimeter of circle, the circumference of circle is equals to the perimeter of square. For this the area of circle will be 4a by pi. I am repeating it again. If the area of square is a, then the area made by the same length of perimeter of the square, the area of circle made by the same square length will be 4a by pi. Means it will be 4a by pi, means it is slightly more, the area is slightly more, because 4a by pi. Next point is area of square, means area of a square minus the area of inscribed circle. The circle is within the square, minus area of inscribed circle. Our inscribed circle is of radius a by 2. The value of the shaded region will be 3 times of a square. 3 times of a square divided by 14. A square will be the area of complete square, and the area of complete square इसका 3 by 14 times होगा आपका एरिया ऑफ शेडेड रीजन. 3 by 14 मीन्स काफ़ी छोटा वैल्यू होगा. 3 by 14 टाइम्स. इसमें 2 केसेस आता है, जिसमें एक बार इंस्क्राइब्ड सर्कल कम्प्लीटली touching the boundary of the square, and in other part, it will be in a part of 1/4 and with the center as the corner of the square. Next point is the area of the largest triangle in a semicircle. It will be the point will be the bisector, the perpendicular bisector of the center, on the circumference will have a corner of the will have a corner with the triangle. So the area of the largest triangle in a semicircle will be r square, will be r square, will be the square times of its radius. Next, coming to triangle. For triangle we have to learn about the side, about the height of triangle, about the hypotenuse of the triangle, then the perimeter of the triangle, and the area. The area is important. The sum of the angles in a triangle is 180 degree. Base and height, if base and height is given, then the area will be half into base into height. If three sides are given, then by Heron's formula we can calculate the area as root under s into s minus a into s minus b into s minus c, where s will be the semi perimeter. And if median PQR is given, then area will be 4 by 3 times. It will be 4 by 3 times. It will be slightly more. 4 by 3 times root under SM in semi perimeter of the median. SM is the semi perimeter of the median. In P plus Q plus R divided by 2 SM is. So it will be 4 by 3 times root under SM into SM minus P into SM minus Q into SM minus R. For isosceles triangle, now all we will learn about the types of triangle. The first types of triangle is isosceles triangle. For isosceles triangle, it is simple for parameter that 2a plus that hypotenuse for isosceles triangle. And about the area, it is like b by 4 into root under 4a square minus b square. It is b into root under 4a square minus b square divided by 4. And where a and b, what are a and b? A is the side which are equal and b is the base. B is the hypotenuse, we can say. It is root under 4a square minus b square whole multiplied by b by 4. So slightly tough formula, so I will make it bolder. Select all and I will bold this formula. And talking about the height, it b by 2 half into base will be cancelled, so it will be root under 4a square minus b square divided by 2 will be the height. For equilateral triangle, perimeter is 3a and area will be root 3a by 4 into a square. It will be root 3a square divided by 4. And for height, it will be root 3a by 2. Means root 3 by 4. And here we have seen 4 by 3. And again here we have seen 3 by 14. So the area of an equilateral triangle is root 3 by 4a square. For an isosceles right angle triangle, the area will be equals to a square divided by 2. Why? Because it is a semi square. It is half of the square. So the area will be a square divided by 2. And its height will be a, but hypotenuse will be root 2a. Now coming to the quadrilateral side. For quadrilateral, we can measure side, we can measure height, we can measure hypotenuse, we can measure, because quadrilateral will contain triangle, set of triangle, two triangle at least, two or many triangles it contain. So we can calculate hypotenuse of those triangle, or we can say the diagonal of the quadrilateral, or we can calculate the perimeter or area. And for a quadrilateral, sum of angles, internal angles, is 360 degree, and the area of any of the quadrilateral will be equals to the length of any diagonal into the sum of the perpendicular falling on the diagonal will be divided by 2. It should be divided by 2, then only the area of the quadrilateral will come. Now coming on to the types of quadrilateral. First type is cyclic quadrilateral. What is a cyclic quadrilateral? A circle in which four sides are inscribed within a circle. Four sides of a quadrilateral is inscribed in a circle, then it is a cyclic quadrilateral. In this, opposite angles, the sum of opposite angle is 180 degrees. Sum is 180 degrees. So it should be noted that the opposite side is not equal, but the sum is equals to 180 degrees. And for the area of this cyclic quadrilateral is root under s into s minus a into s minus b into s minus c, where let me check what is the value of s. So here in cyclic quadrilateral, it is to be noticed that this s is the a plus b plus c plus d divided by 2. It is not the average of the sides, but it is the sum of the side divided by 2. Here also, if you will take about the median sm, here about the median sm, it will be the sum of the median divided by 2. Here also in this semi perimeter, here, where is this one? Let me check. Here in this one, here in this Heron's formula, this semi perimeter depicts is equals to the sum of the sides divided by 2. It's not the average. It is not the average. It is the sum divided by 2. So that's for about the cyclic quadrilateral. We know that the opposite angle sum is 180 degree, and the area of the cyclic quadrilateral we know by s. For trapezium, the area of the trapezium will be sum of parallel side into height divided by 2. It is divided by 2. So now for parallelogram, for perimeter it should for perimeter it is easy that 2 into sum of opposite sides, because opposite sides are equal and parallel, and opposite angles are equal in this case. In this case, opposite angles are equal, and area of parallelogram is equal to base into height, and it is also equal to a b sin theta. Why? Because a is any side and b sin theta is the perpendicular. B sin theta is the perpendicular height of the parallelogram, which is the height between which is the length between the parallel sides. It is also equal to d1 square plus also d1 square plus d2 square is equal to twice of a square plus b square, where d1 and d2 is the diagonal sum of the square of the two diagonals is equal to sum of the square of the two unequal sides. So this equation hold only for parallelogram. For a rhombus, perimeter is equal 4a, and in this diagonals bisect at 90 degree. Diagonals bisect as well as is at 90 degree. And the area of rhombus will be equals to d1 into d2 by 2. d1 and sum of the perpendicular on it is equals to the other diagonal. So that's why d1 into d2 by 2. What about the rectangle? 2 into l plus b is the perimeter. Then here diagonals are equal as well as bisecting as well as at 90 degree. Equal diagonals bisect at equal diagonals only bisect here. This is not at 90 degree. Why it is not at 90 degree? Because all of the sides are not equal. Only if all of the sides are equal, then only it will bisect at 90 degree. And only if the two pair of the sides are parallel, then only it will bisect each other, like in parallelogram. Like in equal diagonals, here diagonals are equal. This is to be noted. Diagonals bisect at 90 degree for rhombus. For parallelogram, diagonals bisect. Here three things are there. For equality of the diagonal, there is three things to remember about the diagonal: equality of the diagonals, and then whether it is bisecting or not, and whether it is at 90 degree or not. These three things to be memorized. So coming back again, for a cyclic quadrilateral, the diagonals need not be equal. The diagonals need not be intersecting at 90 degree, and the diagonals need not be bisecting. For trapezium, diagonals need not be equal. For it need not be at 90 degree, need not be bisecting. For parallelogram, the same, need not be equal, need not be bisecting at 90 degree. For rhombus, need not be equal, and and it is just bisecting at 90 degree for rhombus. For rectangle, it is equal, it is bisecting but not at 90 degree. And area is equals to length into breadth. Everyone knows. Here is one important point, that if the length of a rectangle is increased by a%, length is increased by a%, then breadth should decrease by 100a by 100 plus a% to keep the area same. Other point is that if length and breadth both are increased by x and y%, length by x%, breadth by y%, then the area increases by x plus y into xy divided by 100%. And if both are decreased by xy%, then area decreases by x plus y minus xy by 100%. Now coming about, if a pathway across a rectangle is drawn, means the rectangle is like this and plus type of pathway is drawn in the in between the rectangle, then what will be the area and the perimeter of the pathway? The area will be equals to length plus breadth minus x, the pathway width, minus x into h into x, the width of pathway. It is like L plus b minus x into x. And about the perimeter, it is like 2 into L plus 2L, it is 2L plus 2b minus 4x. 2L plus 2L plus 2b minus 4x, that is middle one. So the area is this L minus some part, and this breadth, complete breadth, L minus this pathway, plus this complete breadth into x. So this is by this way it is simple. If we are taking the plus towards the end of the rectangle, then it is like L minus x plus b or whole multiplied by x. Now perimeter is like simple, it is 2L plus 2b minus 4x. Now if an outer pathway is around the rectangle, then what will be the area? Then what will be the area is L 2L, it will be 2L plus b plus 2x. 2L 2 into L plus b plus 2x and whole multiplied by x. How it should be remembered? So the formula will be like, if there is L plus b and this breadth will be added by 2x, then it will go down and the complete line of the outer rectangle will take place. And if it is multiplied by x, then from one side the area will be taken and then it should be multiplied by 2, so that complete frame will be, area will be taken out. So it will be like L plus x plus 2x and whole multiplied by 2x, whole multiplied by x coming one side of the area and then multiplied by 2, so that coming the complete frame. And talking about the perimeter, then it will be like it is having 4l, it is having 4l minus 8x, 4l plus 4l plus 4b plus 8x, it is having plus 8x, because if you are taking 4l length as 4 length, 4 times of length plus 4 times of breadth, and the corners are left out, they are 8x corners. And for inner pathway, the area will be like, the same way, area will be like length plus breadth minus minus 2x, the length will be taken shorter, minus 2x, and then it will be multiplied by x, then half path, and if it is multiplied by 2x, the complete inner frame. So again, if we are having breadth plus length, and length minus 2x, we are having inner length and outer breadth, inner length and outer breadth multiplied by x, we are getting one side of the area, and then multiplied by 2, we are getting the complete frame. And for coming to the perimeter, there are 4l plus 4 breadth, and it should be minus 8x, because the frame is within the rectangle, so it should be minus 8x. Now coming to the square, for the perimeter of square it is 4a, and here the diagonals are equal as well as bisecting as well as at 90 degree. So this is only the case where 3 property goes correct. Area is equals to a square, which is also is equals to d square by 2, and diagonal is equals to root 2a. If diagonals becomes x times, then the area becomes x square times. This is to be noted here only. If anything is changing to anything is changing more than it, then the area is changing, diagonal is changing x times, then area is changing x square times. In one also case, if there was if the side was changing x times, then its area was here. So if the like here, if the side was changing by x%, then the area was changing to x by 100 plus 2 and whole multiplied by x%. So coming back again here, now to the polygon side, polygon section. In this section we have to study about side, we can study about height, hypotenuse in polygon, diagonals in polygon, about the perimeter of polygons and the area of polygons. Polygons are those figures which have 4 or more than 4 sides. Regular polygons are those polygons in which all of the sides are equal. Then here in this type of polygons, or sum of all the interior angle is equals to n minus 2 into 180 degree. This is not 360 degree like as in the case of quadrilateral. Sum of exterior angle is 360, but sum of interior angle is not 360 degree, it is n minus 2 into 180 degree. It can be more than 360 degree. Interior angle plus exterior angle is equal to 180 degree. Here is the case of 180 degree as well as 360 degree as well as more than 360 degree, depending on the number of sides. Each interior angle is equal to sum of interior angle divided by number of sides. This is a general case in which each individual interior angle is equal to sum of all the interior angle, which is n minus 2 180 divided by the number of side, and exterior angle is equal to 360 divided by n, means n times of each exterior angle is 360 degree. N times of each exterior angle is 360 degree. Here as we have said, sum of exterior angle is equal to n into each exterior angle, because all of the exterior angle are same and it has n side, n into each exterior angle is 360 degree, and each exterior angle is 360 by n. And number of diagonals regular regular polygons having is n into n minus 3 by 2. N into n minus 3. If n is added, here 1 is increased, n into n minus 3 by 2. So n into n minus 3 by 2. This is complicated, no mnemonics present. For area is equal to perimeter, perpendicular distance from center of regular polygons. What does it mean? Area is equals to perimeter. The area is equals to perimeter, perpendicular distance from the center of regular polygons. Now the area of regular polygon is what? The perimeter of the regular polygon into the perpendicular from the center of the regular polygon to any of the side of the polygon. The perpendicular of the polygon into the perimeter of the polygon divided by 2. It will give the area of the regular polygon. Also area of a hexagon, which is a regular polygon. Area of hexagon which has 6 sides. It has 6 equilateral triangles. So the area will be 6 into area of equilateral triangle, which is 6 into root 3 by 4 a square divided by root 3 by 4 a square. So it will be root 3 root 3 a square by 2. Similarly, area of regular octagon will be, it has 8 into area of equilateral triangle, 8 into root 3 by 4 a square. Now coming to the circle portion. A circle, in a circle we can measure chord, angle, diameter, the perimeter and the area. For the area of circle it is pi r square. For the circumference it is 2 pi r. For any r it is theta by 360 into pi r square. Theta by 360 into pi r square. So, and for area of any ring is pi into complete r difference of the square of their radius. For perimeter it is 2 pi into difference of their radius. Based on room question, the area of 4 walls is 2 into L plus B into height. The area of 4 walls including the floor is 2 into L plus B into H plus LB, and the area of 4 walls including the room and the floor and the ceiling is 2 into L plus B plus 2LB, 2 into L plus B into H plus 2LB. So here is the end of today's mensuration 1 2D figure. Meet you in the next video.